So in this video, I'm going to do an example of conservation of energy using a pendulum, right? So if we have a pendulum, it's going to be attached by some sort of string, right? And if we have it at an angle, and we allow that object to, or release that object, it's going to swing back and forth like this. Now, it's going to swing to some relatively low position, which would be down here. Okay, so if we went and we passed right through this position here, this would actually be equal to the length of the pendulum arm, right? Because as we swing down, the arm length doesn't change. So let's say that we have a ball that's on the end of this, and it's 2 kilograms. We'll just keep using that as an example. And let's say the length of the pendulum arm is 1.5 meters. Alright? Now, when we are right here, let's say that at this position, let's just try and keep it to size, I'm 0.3 meters above the relative low position here. So as I lift this pendulum up in this direction, right, I lift it 0.3 meters high. So up here it has some gravitational potential energy because it's above the ground. If I allow it to release, then as it swings and it gets lower to down here where we're saying h is equal to 0, then all of that gravitational potential energy, again, will be converted to kinetic energy. So in an instant like this, I can set gravitational potential energy equivalent to kinetic energy. And this is at the top of the swing, and this is at the bottom of the swing. So let's figure out how fast it's going when it gets to the bottom. So we have that mgh is equal to 1/2 mv squared, and in a lot of these instances the mass is going to cancel like we've seen before. So we just have gravity, which is 10 times 0.3 equals 1/2 v squared. So my answer would actually be the square root of 6. Let's see what that is. So 10 times 0.3 is 3, and then if I divide that by 0.5, I get 6, and then I take the square root, and I get 2.45. So my velocity is 2.45 meters per second at the bottom of the swing. So pendulums can be calculated the same way as if we're dropping a ball or if we're going down an inclined plane. We're just looking at the change in gravitational potential energy being equivalent to kinetic energy.